Thank you very much, Karen, for giving Space Talk the opportunity to interview you. I am very excited to learn more about your software engineering career and how that led to Rocket Lab and what you're currently doing. So it's quite exciting. Thank you so much for making the time.
Thank you for having me.
Um, so Karen, so to begin with, can you tell me what led you to study software engineering and how that led to then Rocket Lab?
Yeah, sure. So, growing up, I've always liked computers and like technology and stuff. I always just was really interested in it. And then when I was thinking about what to study after school, um, it was kind of like, oh, software engineering or computer science. And I thought engineering sounded more hands-on. I didn't actually, so at our university, we had different specializations, and I didn't actually get into software engineering because my grades weren't high enough. So I ended up in computer systems engineering instead, which is still still involved coding, and it was pretty similar, but it was a little bit different to what I initially planned. And getting a job at Rocket Lab was just I was just looking for a job. In order to graduate, we needed practical working hours,
Yes.
and they had a job opening open for interns. So this was before Electron had launched ever, and yeah, and I thought I'd just apply because I thought the skills they were looking for had aligned with what I'd been learning in computer systems engineering. So I just went through the process and I got a job as an intern.
Oh, that's incredible. Congratulations on that.
Thank you. So yeah, I've just worked my way. Yeah, I've graduated since and now I'm a full-timer, but yeah, I kind of just went, that's how I got my foot in the door at Rocket Lab.
So you said you went into computer systems, is that right? You were studying
Yeah,
computer.
that's
So
correct.
what's the difference with computer systems and software engineering?
So, well, at our university, software engineering was a lot of, I guess, like app development and that sort of thing. Whereas in computer systems, it is kind of the bridge between hardware and software. So we did a bit of electronics, but we also learnt a lot of the coding and the software side of things. And that's what I do in my job at Rocket Lab, which is kind of write the code that's the bridge between software and hardware, which, yeah.
Oh, that's incredible. Wow. So can you take us through what is a typical day as a engineer and what it looks like at Rocket Lab and most importantly what are you building as well?
Sure. So I am in the flight software team. So that means we develop a lot of the code that talks to different hardware on the vehicle, so sensors and things like that, and we help extract that data and work with the other software teams in the company to make that data available to all the other rocket engineers who will then process the data and I guess learn about our vehicle that way. So we're in our team, we develop a lot of software that talks to a whole lot of hardware. So especially for new additions onto our rocket, like recovery systems or starting to develop stuff for our Photon satellite bus or for Capstone. So we work on a lot of new development. We also maintain our current software and support all of those things through systems testing and all the way through to launch. And sometimes just a mix of all of these things, sometimes all in one day.
Wow.
Is found in a typical day. Yeah, so it's pretty, yeah, there's a big range that we work through.
And with what you're doing, you were actually involved with the booster recovery that recently happened. Is that right?
Yeah, so
So
I helped set up a lot of the I guess a lot of the ground station stuff that they took with them on the boat to help track down the rocket. So yeah, just kind of tested and everything and made sure that was ready to go. So the team out there had some sort of telemetry to use to kind of stay informed of where the rocket was. Yeah, it was awesome.
Wow, that's incredible. part of history.
Yeah, yeah.
So can you tell us more about how you will be launching NASA's Capstone CubeSat to a unique lunar orbit and the importance of software engineering for this mission?
Yeah, so it's a pretty crazy mission. So we'll be launching Capstone through a series of relights at Panoedjoe, so we can raise the apogee and like gradually build to a translunar trajectory. And for us in software, that means we're having to adapt electron and photon to support a mission like this. It's something we've never done before. So that means, you know, adding new hardware, which we will then write software for, or adapting our current software to drive things. So a big example is we'll be adapting our current Curie engine to hypercurie. And there's going to be a whole lot of different teams just basically building on what we already have into I guess, a flashy new version that will take us to a lunar orbit.
Wow. So the code that you're writing is actually it's actually integrating these two systems. Is that right? Just trying to get a better understanding of what's actually happening when it's sent into, you know, into orbit and how that sort of connects.
Yeah, so we'll be taking a lot of sensor data. Maybe that's figuring out like temperatures and things like that, or controlling valves and things. And yeah, we write a lot of the software that makes sure that operates correctly and that operates safely.
Wow. Okay. Well, with that being said, what are the challenges that you currently face as a software engineer, and how do you address those challenges?
There's a lot of problem solving. And as I said before, there's lots of different things happening at once. So we're always having to kind of do a lot of context switching. So 1 hour I'm working on this system, and then next thing on my list is something completely different. And I have to kind of be like, okay, now I have to switch to this mode and to think in this way. I end up addressing these challenges by writing down a lot of to-do lists, just to kind of slow down and breathe a bit, gather my thoughts on those particularly busy days, and just kind of like, these are the things I need to work through. And then there's that feeling of accomplishment where you can kind of cross it off the list. Yes. And to just make sure I don't forget anything, and that I am ticking off the things that need to be done urgently. If you ever take a look at my notebook at work, it's just filled of like really random, unorganized thoughts, just to make sure I don't forget them when I do need to come back to it. Yeah, and also communication between teams is also really important, but it's quite a bit of a challenge. So just because I understand things from a software point of view, but not everyone in the company is going to think that way. So trying to communicate our ideas in a way that, you know, a mechanical engineer would understand versus a software engineer is something I'm still learning, just because, yeah, I'm not particularly mechanically minded. Yeah.
No, that's yeah, I love how you mentioned about, you know, keeping your tasks in order and, you know, crossing it. It does feel, you know, like you've achieved a lot. So when I get to cross my own task list as well. So Karen, I mean, in your opinion, what innovations will need to be achieved? And we're going into a different section now. We're gonna go into the Mars, you know, innovations here. What innovations will need to be achieved in software engineering to be able to achieve to go to Mars?
So because I kind of got into Rocket Lab just because I needed a job, I didn't really grow up being like, yeah, space. I kind of learned about space as I grew into my role at Rocket Lab and just hearing everyone else talk about the space industry. So I think in terms of that, I think we should just use what we've got today, because we're always going to be innovating, right? And but if we're saying, oh, we won't go to Mars until this and this and this happens, we'll never get there. I think there needs to be, someone just needs to start, use what we've got today. Technology may change as we develop a roadmap to Mars, and then that's okay. Let's integrate, the upcoming technology into our current thing, and then just keep building on that. But yeah, otherwise, if we're just waiting for certain innovations or technologies to come about before we start finding a way to get to Mars, we're never going to get there, if you get what I mean.
Yeah, absolutely. We can't be waiting. We just have to keep going. Yeah, absolutely. So with your experience, what software systems do you think that we need to be able to sustain life on the moon and on Mars, especially now you are involved in actually going to the moon? Can you sort of take us through this?
Yeah, that's an interesting question. So I think, I don't know, when I was thinking about this question, I just thought a really interesting challenge to solve would be, I don't know, some way of managing energy sources or something to power whatever that we will need to be able to sustain life on the moon and Mars. I have no idea what that would look like, but yeah, I guess if we're bringing a whole lot of devices and things and we're used to powering them with electricity, what do we have over there? I have no idea. So yeah, I think that would be a really interesting thing to tackle.
Oh, absolutely. And we need energy to be able to, like you said, be able to sustain life. So
exactly, yeah.
Yeah, that's a really good one. So what changes do you think will happen in the next 10 years in your in software engineering?
Ooh. I think software is quite broad, especially like the stuff I work in is kind of talking to hardware. So it's very low level, quite close to electronics. But then there's also in software things like big data and machine learning and how we can use a whole lot of data to learn about different systems. And I think that's a massive thing in software engineering. And also with the way that this private space industry is moving. I personally hope it will pave the way for rapid spacecraft development. So maybe like more embedded platforms to help people get started in developing their own spacecraft. I think as an embedded engineer, that's kind of something I think would be really cool to see or to be a part of. Yeah.
Oh, no, that's and it's going to change so much in the next thing. Like you said, with the private sector coming in, we're already having all these innovations happening, and there's no doubt, everything is going to change, and we'll definitely get there. So,
yeah.
And Karen, for our last question, for those who are considering a career in software embedded engineering, what programming languages would you recommend, learning during their undergrad?
So I started out in my undergrad learning C. That was a compulsory course for a lot of us. And that really helps if you're wanting to get into that low level embedded, so C or C++. If you've never coded before and you want to, the language Python is really good. It's super versatile, and yeah, it's a really good start to software development as a whole. And there's so many resources online to help you learn both C and C++ and Python. And I think, yeah, don't be afraid to explore different languages and things. You never know what new languages will be around in the future as well, or when you leave undergrad, what will be there. So yeah, just kind of read up, see what's around. But I personally think C or C++ and Python are really good starting points.
Perfect, Karen. Yeah, because it's quite important, I believe for any student that is wanting to get into coding and especially join the space industry to understand where to focus their attention when they're looking at coding and how that's going to impact them future on. So I think that's really good. Thank you very much for that. Karen, I really want to appreciate the time that you've given us and to say thank you for everything, for answering here our questions and giving us a bit of a sense of what you do and your experience and your thoughts on what the future will be. It's been absolutely incredible speaking with you. I really appreciate it.
Oh, you're very welcome. Thank you for having me. It's been an honor.
Thank you, Karen. And is there any, would you be okay for our viewers to reach out to you if they do need to? And if so, is there any social media links that they can reach you on?
I think, you'll find me on LinkedIn. Yeah.
Link is the way, and I'll add in the details on there. So, well, thank you. Thank you very much, Karen. I really appreciate your time.
No worries.